So we've demonstrated how to change our interpreter to have an object-oriented style to still implement curly as a lambda-based functional language. Now we're going to flip things around. We're going to go back to our regular way of implementing interpreters because it was nice using typecase and so on. But we're going to implement an object-oriented variant of curly. That is, we're going to implement the objects in the get and send as the primitive forms in our interpreter. So that means the new curly language has expressions like plus and times, and we'll just leave those things alone. But we're taking away lambda and application. Instead, we're going to have object, get, and send. I should also say we're taking away let because that goes to lambda. So we're not going to have any local variables, but we will have objects that have fields inside of them. A field is going to be just a sequence, a symbol with its initialization expression. And then each method is written as a symbol for the method name. It's always going to be arg as the name of the argument, and then a body expression for the method. So you see that the things that we need to keep for fields and methods are the same, but for the field, this expression is evaluated when the object is created, because that gets us the initial value for the field in the object, whereas the expression in a method, that's going to be delayed until the method is actually called. And we don't need to keep this arg because it's always going to be the arg identifier. The method is always going to take that one identifier, called arg, and it can use arg with other expressions in the body along with this argument that's always available. Right? We can use this to get fields of the current object or to call methods of the current object. In field, we don't have this in arg because those are things that work inside of methods. So if we use them in a field expression, then they must be from some surrounding objects method, which means that we can nest objects in the same way that we used to nest lambdas because objects are the fundamental thing here. So for example, we can have this expression as our whole program. This is an object that has an x field and a y field and no methods. The value for the x field is produced by interpreting 1, so we just get 1 for the x and 2 for the y. And here's an object where we have a more interesting expression for y, but still it's evaluated when the object is created, so we still get x is 1 and y is 2 in the resulting object. If we have an object like that with fields x and y, then we can use it with get, which takes an object and a field name and goes and gets the value for that field in the object. So that expression, get of object, etc., will give us 1 back. Here's an object that has no fields but has one method called increment, and it takes its argument and adds 1 to the argument. So if we have that object, we can call the increment method using send. And the syntax is send, the expression for the object, the name of the method, and then the argument that we pass in. So 2 is going in as the argument to this method, and that's how we get 3 out. Here I've got an object with 2 methods, increment and decrement, and decrement does the obvious thing. And here I've got a method that's a Manhattan distance method that ignores its argument, but it uses get on this to extract the x and y fields of this object. So this is a kind of position object with an mdist method that returns 3 because it's 1 plus 2. And then here's how we would call that mdist method on that object. So we've got the object, we send it the mdist method with argument 0. The 0 is just a dummy argument because there has to be one, but we get the 3 back as expected.